Okay. So here's some bad news. Well, before I start talking, let's pause and copy. Pause and copy. Okay, bad news. Bad news. Not every function has an antiderivative in terms of elementary functions. So, elementary functions are your usual functions, your trig functions, your exponentials, your polynomials. So can't always find antiderivatives. Okay, so that means that FTC is no longer available. So we're going to have to use some kind of approximation. We've seen this already. We've done some approximations doing L4 and R4. Okay, but we're going to improve a little bit on that with something called the trapezoidal rule. So pause and copy this diagram down. So what I have here is in blue, there should be straight lines going across. I've had a bit too much coffee today, so it's a bit wiggly in spots, but these should be straight lines across here. Straight line across here to form a trapezoid. Okay, so pause and copy. Pause and copy. So we got trapezoid number 1, number 2, number 3, and number 4. And you can see this is an improvement over what we were doing with, say, L4 and R4. Because with those, we were just kind of going straight across here, right? And with the trapezoid, you get a better fit to the function. Okay, so to approximate the integral, just give me a second here. All right, pause and copy all this. Pause and copy. So to approximate, I'm going to add up the areas of those 4 trapezoids. That's what I'm doing here. There's a formula from geometry for the area of a trapezoid. It's you take this average of the 2 heights. Okay, so if I look at trapezoid 4 here, you have this smaller height here and this larger height there. So I take the average of those 2 heights and times by base, and that's what I get to give me this line here. I factor out the delta x over 2, comes out here, and I collect like terms inside the square bracket, and what you get is this thing here. You may want to copy out this to see the details, but the idea is that this f of x1 is going to appear twice in the next term here, which I haven't written. This f of x1 is going to appear again, so that gives me a 2 right there. Anywho, it shows the formula, and this is when I have 4 subintervals, but when I have n subintervals, I get this formula here. Okay, we call this the trapezoidal rule. So pause and copy this stuff in red. Pause and copy. Okay, I want you to notice that we're using every one of our endpoints. So if I were doing L4, I'd be using just these endpoints. If I were doing R4, I would be using just these endpoints. But now, quite differently, for trapezoidal rule, I'm using actually 5 endpoints. I'm using all the endpoints. Okay, let's do an example. So pause and copy this example here. Pause and copy. Pause and copy. Okay. So let's see what we get here. So this is approximately equal to um, delta x over 2. And we have n equals 4, so I'm going to go f of x 0 plus 2 f of x1 plus 2 f of x2 plus 2 f of x3. And then the last term is the n there. I'm just using my formula, which is up here. Yes, this last term has the n. Okay, sorry, stop scrolling. Okay, what's delta x? Delta x is equal to b minus a over n, as usual. So 3 minus 1 over 4, which is a half. So what do I get? I get a half divided by 2, square bracket. Maybe I should write down my x's. That'd be useful. So x0 is a, which is 1. And then I add a half to move forward. X4 is my 3. So this is a, and x1, I could think of it as a plus delta x if you want. Anyways. So is this 1 squared minus 1? Is my function here. Plus 2 and finally 3 squared minus 1. So let me just double check I got that right. Okay, looks good. So I do that, and I use my calculator, and you should get 6.75. Now, what should we do next? So I'll give you one exercise to try in this section. We will do the e to the x squared I mentioned before. Oops, I forgot to do part B, didn't I? Boop, boop, boop. B. Okay, so for part B, we're going to use FTC. So we get x cubed over 3 minus x from 1 to 3. And what is that? 9 minus 3 minus third minus 1, which is equal to 6 plus 2/3. which is 6.6 repeating. Yeah. So we can see that this number is not too far from the exact value. Okay, now let's do our exercise. Okay, use trapezoidal rule with n is equal to 6 to approximate. The integral 0 to 1 e to the x squared dx. Okay, pause, give that a try, and I will go looking for the solution and post it on the screen here. So, looking. Um, no, lecture notes. Almost got it. Don't worry. Don't. Found it. Okay, here it comes. Bam, solution. So hopefully you got something close to that. If not, let me know during class.